Okay, so our next step is to introduce you quantitative data graphs. Okay, so basically these are data graphs that are used to draw to depict quantitative data. Okay, let's see what are them. So the first one is histogram. Well, histogram, you can say that it is just a direct depiction of a frequency distribution. Once you are given a frequency distribution like this, to construct a histogram, all you need to do is to plot bars for each of these classes. Okay, you can see that the first interval is depicted here, the second interval is depicted here, and so on and so on. And altogether, a histogram is a graphical description of a frequency distribution. Okay, with a histogram like this, you can directly see that most of the daily rentals are around. Most of the daily rentals are around 4,000 and 5,000, and extreme cases are rare, and so on and so on. Okay, you can have a very rough idea about the distribution of your data set. Regarding the graph itself, there are some things to keep in mind. First, of course, you need to know what's required for histogram. A histogram must have a series of contiguous rectangles, each representing the frequency in a class. Contiguous here is a key word. You need to make sure that all the rectangles are connected with each other. Okay, there should not be a hole here. There should not be a hole here. These rectangles should be connected to each other, should be attached to each other. Okay, so there should be contiguous. This is very important because once you don't do that, then technically you cannot say that you are drawing a histogram. Okay, so please keep this in mind. Histograms may be the most important type of data graphs, or we should say that regarding statistical methods, histograms is the most useful. One particular reason is that we want to get some ideas about the distribution. Like we want to ask whether it is a bell-shaped distribution, M-shaped distribution, or whether it is symmetric or skewed, and so on and so on. Okay, we will talk about distributions in more details in the future classes. Also, a histogram would be a basis for you to do some statistical test about whether this set of sample data can help you understand your population data in this way or that way. Okay, so being able to draw histogram has at least two meanings. First, it helps you to get an intuition about the distribution of your data set. And the second, it will be the basis, be the foundation for applying some statistical methods. Okay, so it is just important. One thing that is very similar is called frequency polygons. Okay, if you don't like histogram, you may draw a frequency polygon by using line segments to connect dots plotted at the class midpoints. Okay, if you look at this frequency polygon, you can see that it simply gives you the same information as a histogram does, right? It simply replaces those bars by a few line segments. Okay, and once a bar is longer, that particular point would be higher. Okay, so from this perspective, a frequency polygon is just the same as a histogram. But of course, there can be some differences. One is that if you want to compare multiple frequency distributions, then using a frequency polygon would be much easier. Okay, just like in this example, suppose that I want to depict the frequency distribution for my CNT columns in the 2011, 2012, and in the 2 years altogether. Okay, then the blue line, of course, is just the frequency polygon I depicted in the previous slides. And then the red line is for 2011 and the green line is for 2012. Be aware of the meanings of these lines. Okay, these are depicting your frequency distributions, or in some sense frequencies. As you know, in the data set, the daily rentals or the total number of rentals in 2011 is generally smaller than those in 2012 because the rentals are in an increasing trend. So that's why in 2012, you can see that most of the daily rentals falls in the regions that are quite high. There are many days that have around 6,000 daily rentals. There are many days that has around 7,000 daily rentals. But for 2011, most daily rentals are still around 4,000, or even a lot are around 1,000 or 2,000. Okay, so when you see these lines, then you can somehow understand whether in this year most daily rentals are large or relatively small. Okay, if you instead use 3 separated histograms and put them together, your graph will be somewhat messy, and it will be not as easy as drawing 3 lines on one single plot. Okay, so when you want to compare multiple frequency distributions, frequency polygons would be better than a lot of histograms. Okay, using this, let's also give you some very brief discussion about distributions, or about the shape of distributions. For this blue curve, we say that it is a unimodal curve because basically it only has a mode here. Okay, there's only one peak at the center of this distribution. On the other hand, in 2011, we say it is a bimodal distribution because basically you have 2 peaks here. For the 2012 data set, it's obviously a unimodal data because there is only one peak. Actually, for the blue line, you probably have a question. It's about whether here is called a peak or not. Okay, technically it is, but compared to another peak that is really significant, this peak is so small and relatively unimportant. Okay, so in this case, for the blue line, people typically say, well, it's at least very close to unimodal. We typically, in this case, do not want to emphasize that there is also a small peak here. But you probably don't want to do that for 2011, because for 2011, this second peak is relatively more important. So you probably don't want to skip it when you describe the data set. Also, these 3 curves are symmetric, skewed to the right and skewed to the left. The blue one, okay, something like this, is basically a symmetric data set. So a symmetric distribution. There is a peak at the center, and its left half and the right half are roughly the same. Okay, it cannot be identical, but roughly the same. For 2011, for the red curve, it has a long tail at the right. Okay, most of the data are at the left. In this case, we say it is skewed to the right. Skewed to the right. There is a right tail. For the 2012 curve, well, the peak is here, so it's skewed to the left. So the skewness or symmetricness are important when you want to describe a distribution. And how many modes do you have is also another important thing to know. Okay, so all of them can be visualized with histogram or with frequency polygons. So frequency polygons are good, but they also have one drawback, is that people may misinterpret a frequency polygon as a line chart, which is typically for time sequences. When you see a curve or a few line segments like this, you somehow directly has an intuition that the quantity is going up and down and then up and then down. But actually from left to right, nothing is related to time, right? So you won't say that, okay, that the quantity is first increasing and then decreasing, something like that. It's just meaningless. It's just not something describing your true data set. This is describing a frequency polygon, not a time series. So using lines can be dangerous. You need to make sure that people really know what is your x-axis. Okay, so let's talk about line charts. A line chart is useful in depicting a time series data, okay, which means your x-axis is for time. It visualizes how a quantity changes as time goes by. For example, for our monthly bike rentals that we focused on in our datasheet last time, we can depict all the monthly rentals as points and then simply connect them. We will get a time series sequence like this, or we can get a line chart like this. With this, we can immediately see a trend going from small to large. We can also see a very clear seasonality. For summer times, we have a higher daily rentals and so on and so on. So time series data can be very easily and appropriately depicted with line charts like this. The the horizontal labels should always be time, and the y labels are typically frequencies. Okay, so these are some ways to visualize our quantitative data points, quantitative data. In the next video, we will talk about qualitative data graphs. Thank you.